Once again, it's Professor Elliott, and continuing on in our discussion on thyristors, we will talk about the Diac and the TRIAC devices today. So the TRIAC. So TRIACs are used in applications where it is necessary to control the power flow over a complete cycle. Recall from our previous class discussions on the SCR, how current flows in one direction only. So essentially, the TRIAC is really just two SCRs connected back to back. Okay, so times two. It's hard to do this with the mouse. SCRs. Okay, so therefore you can control the conduction in both current directions. The terminals are the gate, anode 1 and anode 2. Notice that there's no cathode terminal. So internally, okay, so here's the construction. And if we call back to the SCR, okay, so we have an SCR here. We have an SCR here. Notice how Q1, Q3 are opposite, Q2, Q4 are opposite, right? Therefore, we have A1, we have A2, like that. We have the gate lead there, and the gate lead there. Okay, so if we apply it with the gate pulse like that, anode A1, positive with back to anode A2, and then that means current then can flow this way down through Q1 and Q2, and these two transistors Q3 and Q4 are off because of that's the emitter diode, so positive to negative. The cathode is facing the anode, so this is going to be off, and likewise this one's going to be off, or this one's going to be forward biased, then providing current down like that, and then current then flows like that, and then out the other side. Okay, all right. So we just changed the polarity around because we said the TRIAC can conduct in both directions, negative to positive. So this is negative, so this one here is going to be off, right? So this is off, and this is off, but this one can be forward biased, and current then will flow down, provide the base current like that, and then out, okay, and also provide the positive gate pulse to turn on. Okay, the Diac. The Diacs are, so all these devices are very, very, very similar, are essentially an SCR minus the gate lead, so it must reach the forward breakover voltage, which you can get from the data sheet, in order to initiate forward conduction. These are bidirectional devices, so current can flow in both directions. Okay, and it's essentially a complementary pair of 4-layer diodes back to back, and we have two terminals, anode 1 and anode 2. Okay, so there's the schematic symbol. Compared to the SCR, this is no gate lead, so there's two terminals. Okay, right, no gate. Like that. There, okay. The internal construction. sorry. And so in order to initiate conduction, it must reach the forward breakover voltage. So if it's either going to conduct this way, if the polarity is positive to minus, or we'll change our pen color, let's go with blue, or if it's going to be minus to plus, and then current's going to flow, go conventional flow like that way, depending, so it can conduct in both half cycles. So sometimes the Diac is used as a trigger device to provide a nice sharp gate pulse to the SCR or the TRIAC, or it can be just used just on its own as a back-to-back 4-layer diode. Okay, so now we're looking at the SES, also known as the silicon controlled switch. And it's used as basically as a sort of on-off device. It's technically not a thyristor. The devices we've talked about so far are thyristors, so it's not properly classified as a power device. Currents are in milliamps as opposed to the ampere range. And applications are oscillators, computers, and other circuits. And the terminals we have are the anode, cathode, anode gate, and the cathode gate. Okay, this symbol. And so anyway, so we included it here in case you see it, so you know what it is. Basically, the idea is that you can provide initiate conduction by providing a pulse here, right? In that case, then you can turn it off by providing a pulse here, or if you turn it on, provide a pulse here. You can turn it off by providing a pulse here. So the advantage of this is it can switch on and off much faster. So it can be used in high-speed digital circuits. The TRIAC and the SCR are much slower by comparison. So it can be used in high-speed switching circuits. So, okay, so I think that's the end of this one, and we'll catch y'all soon. Bye-bye.